So, in the previous lecture, we were discussing about slicing in arrays. Okay, so let's proceed ahead with some more codes related to slicing in Numpy. For example, I am available with this particular code. That means I have created a 2D array. Okay, you can see that there are two brackets here. So, according to those two square brackets, we understand that this is a Numpy array. Okay, and then what we do here is first I have printed this array. Okay, I have printed this array, all right, with print arr because I have given the name arr to the array. Okay, after printing this array, what I am going to do here is I am taking arr1, which is equal to arr1 colon and 2 colon. Okay, that means first of all you will be understanding what this array actually is. Okay, so here it has been printed. This array has been printed. Okay, and then we are looking forward for what does 1 colon and 2 colon means. You know that, sir, this is for the rows and this is for the columns. Okay, so if I say 1 colon, okay, so here that means you need to print this particular row. Okay, that means you are going to focus upon this particular row. And then if I say 2 colon, that means all the columns from 2. Okay, so here I'm going to take all the rows from 1. Okay, and in the next case I'm going to take all the columns from 2. So this is column row number 1, this is row number 2. These two I need to consider. Then I need to consider the columns 2, and after all your this column 2. So this is column number, which one is column number 2? This one. Okay, and remaining all columns, this column and this column will also be considered. So your output, this is your sliced numpy array. So it's quite simple. Okay, and we have seen this kind of stuff in list slicing also. So things are all are similar. Okay, now if you want to update the value, okay, for example, here in this case I have again taken the 2D array, numpy array. Okay, and I performed the same slicing which I did above, 1 colon and the 2 colon. Okay, and then what I did is I updated the value of arr 1 0 comma 2. Okay, so you can perform this operation. All right, how to update the value of array 1 0 comma 2? That means what it's asking for. Okay, where is this 0 comma 2? First let me check what is arr1. So this is your arr1. Okay, this is your arr1. And what I'm going to do is I am updating the value of sliced array. Remember what I'm doing. Array 1 is a sliced array, and I am saying the value of 0 comma 2 should be 88. Now, sir, 0 comma 2, that means are you talking about column number row number 0, and 2 means are you talking about column number 2? So this is row number 0 and column number 2 is this thing. Okay, column number 2 is this thing. Okay, so are you talking to update this value 8 by 88? Okay, and if I update the value of sliced numpy array, and then I printed the actual array. When I printed the actual array, what happened? The changes are reflected back to the actual array. So understand this code, what's happening. Things are very simple, but the result which we came is something which we need to think upon. This is your initial array. You have done slicing of this array and created a new array, that is arr1. Then you have updated the value of arr1 at 0th row and second column. You say my value is 88, and after updating the value, when I printed actual array, I am not talking about let me print this arr1. If you want, we can do that. Okay, let us print arr1 also. Okay, but we know that, sir, ARR1 is actually changed. Na? You have already changed. So printing that means always we print the changed array will be printed. But what happened to initial array? Okay, so if I do run this code, okay, I found that my ARR1 is also changed, and accordingly, my initial array is also changed. Okay, so if you do work upon the changes in sliced array also, it will be reflected back to your actual array also. Okay, So that was I need to explain you. In the next case, let us consider that here again is your array, that is a 2D array, and I am performing slicing like this: 2 colon and colon. That means 2 colon means, that means consider all the rows 2 and afterwards. Okay, all rows needs to be considered. And colon means, okay, consider all the columns. Okay, this is how I need to create an array. And then when I am printing the shape of the sliced array, that means first I'm printing the sliced array, then I'm printing the shape of the sliced array. So what I am getting here, okay, here is your sliced array, and here is its shape: 1 comma 5. That means it is having, it's a 2D. 1 comma 5, that means it is a 2D. It is having one row and having 5 columns. Yeah, I got it correct. Yeah, by seeing this array only I can understand that it is having one row and the 5 columns. All right. So this is quite simple. I'm just doing the slicing, and I'm just printing the shape of the array, sliced array. That's it. Okay. In the next case, in the next case, here I believe that both these codes are same. Okay. So let us consider another code. Fine. Zeros. There is a method called as zeros in Numpy. So import numpy as np a4 equal to np dot zeros. What this zeros means and what you are going giving in this method: 2 comma 3. So this zeros 2 comma 3 is saying that you need to prepare an array of rank 2 with all zeros. That means it should have 2 rows and 3 columns. Okay, so here we are having 2 rows and the 3 columns. Okay, for a matrix which is having all the zeros. Previously we have seen one method which is printing once. Okay, now I am available with the zeros. Okay, so that is also possible here in case of the numpy. Okay, so here you are creating a matrix of rank 2 with all the zeros, and you are having 2 comma 3. That means you are having 2 rows and the 3 columns, and it's up to you what shape you want to give. Okay, if you will say, sir, is there any possibility I want to skip this particular part? That means I'm just going to write np dot zeros 2 comma. Okay, so what will be the resultant list, or I would say what will the resultant array? Okay, here, so here is a resultant array. That means you are having what you are saying, 2 comma na, 2 comma na. That means I am having only one array. Okay, one row in this particular thing, and with the 2 columns. Okay, so just uncomment this particular thing which we have taken from above. So it's just like 2 comma 2 comma. That means I am having 2 elements only in this particular array. That's it. Now if you just say, sir, any other possibility, can you write like this: comma 3 comma 3? Is this possible? Is it possible or what? Let me run this code. You're going to get an error because this is invalid syntax. You can't write comma 3. This is nonsense. You can write 2 comma 3 comma whatsoever. That is a, that will be in a 1D format. Okay, so here writing that particular stuff is not at all valid. Okay, so you should be understanding, in many of the cases you will be getting this kind of structure. Okay, because for example, we are available with the data set. Okay, in our data set there are many features, there are many columns, for example 10 columns. And what I used to do is I need to separate my data in such a way that 9 features I am going to take separately, and the 10th feature I need to get it separately. So the 9 feature will be having some this kind of, that means 2D, something like that. Okay, but that 1th feature, that is the 10th one which I'm going to take separately, that is going to behave like this thing. Okay, because it is having only one D structure. Okay, so you will be seeing this thing. That's why I have told you that if you are writing 2 3, that means it is having 2 rows and the 3 columns. But if you are writing 2 comma, then it is having just only 2 elements here. Okay, and having only one row. And if you say, sir, can I have like this also? Can I take 3 comma 3 comma, then what will happen? Sir, it is having your 3 0. Sir, can we drop the comma also? I'm dropping the comma. Let me run this code. Then also it will be same. Okay, so it's up to you how much experiment you can do on the particular code, and don't worry about the error. Okay, just do it. Okay, I first understand the concept, what it has been meant for, how to do coding. You need to understand. Okay, zeros means, okay, that means I need to have a array. I'm going to prepare an array of zeros. Okay, fine, done. Then this is how you can create it, sir. Two rows and the three columns. This is how I can create it. All right, after that, sir, can I skip this particular part? Three, yeah, I can. Now it will be like a 1D stuff. Okay, can I skip, sir, comma also? Yes, you can. Still it is a 1D stuff. Okay, and sir, it is mandatory to write inside double rounded brackets. Is it, or you can just have a single thing also, single rounded brackets also? What is the possibility? Okay, for example, if I write like this, okay, and then I run the code. Now it says cannot interpret three as a data type. Now there is an issue. It cannot interpret three as a data type. Okay, so it is mandatory that you should have to write all these under double rounded brackets. Now it will interpret. Okay, so you can do changes from your side and understand that whether my code is running fine, on what instances my code is running fine. First, you need to understand what actually this method is. Okay, so it is for the zeros. Now there is another method that is called as a full. That means I need to fill up my array with some value. I need to fill my array with some value. So for example, I need to take np.full 2 comma 3 comma 8. That means I need to prepare an array of rank 2, or I need to prepare an array with 2 rows and the 3 columns, and I need to fill it with the value 8. Fill all the values with 8. Okay, previously we are already available with the function zeros, so no need to put anything else. But here, if I need to put the value full, I'm using the method full. Okay, so I can fill that particular matrix with this particular value. Okay, and then I'm printing it, so it's 8 8, all the things. Okay, if I do consider this, okay, and prepare another code. Okay, and if I say, sir, whether it will be 11, okay, and let me skip this part 3. This is possible or not? So here it is. I already told you, you can skip this particular value. Okay, so here it will be like a 1D stuff. Okay, with 11 value, 211 values will be filled. You can do that. Okay, so full is something where you can fill, you can create a array of that particular value. Okay, I, another method. See, I stands for identity matrix. Okay, and identity matrix means what actually it has. You are having all diagonal elements as 1. This is your identity. Okay, so if I'm preparing I4, that means it's going to create me 4 cross 4 matrix. Okay, with all the diagonal elements as 1. Okay, so if I do copy and here it doesn't mean that you need to give 4 comma 4. No, if you give 4 only na, then it will consider. And if you give 10, what will happen? It will, if you give 10, then what will be the shape? You can understand that here in diagonal I am having all ones, remaining all is 0. Okay, so you can use a method I to create such kind of matrix. This is again a 2D matrix. Okay, now, so we have seen zeros, we have seen full, we have seen I. Okay, what's next? If you want to create a numpy array with random numbers, okay, so for that reason, you can perform a task that you are available with already random method in numpy. Okay, so I am picking np.random.random. So you are available with already this class, or I would say random is an object, or I would say whatever. If numpy is an object to the numpy class, This has been random is an object to the random class which is present in numpy, and I'm going to access this method random from random. Okay, and I'm saying 2 comma 4, that means I need to create um array of 2 rows and the 4 columns, or I would say array of rank 2, and I need to fill it with the random values. Okay, so right now you are seeing that I am having 2 rows and the 4 columns with all these random values. Okay, right now you are seeing this. If I run this code again, it may possible that values get changed, and they changed because it's a random. Okay, so between 0 to 1, here all the values between 0 to 1. See, with the random values in half open interval, that is between 0 to 1, where 0 is included and 1 is excluded. You will never get 1 here, but you can get 0 here, and it's random. Multiple times, if you run this code now, it may happen that you will get different values. Okay, so we are creating a matrix with the random values using random method. Okay, now this is I have already explained to you. So I got different methods in numpy. Okay, taking ones also, zeros also. Okay, and then full also, I also. Okay, and random also. These are already predefined methods in numpy, and you can create a matrix from your side by using them. Now, in this particular code, you are aware that, sir, you are taking a list, you are printing a list, you are converting this list into array, and then you are printing this array. This is what you are doing. So, you can check the difference between the structure. This is a list separated by comma. Okay, and this is an array, they are not separated by comma. So, that is a difference. Though we are having square brackets outside also, or don't interpret it as a string. Okay, it is your, this one is your array. Okay, and this is your list. All right, separated by comma. Now, if you want to change the data type from float to integer, if you are going to create an array, okay, and if you are changing the data type from float to integer, it is possible. And I hope you have already seen as type method previously also. For example, this is my array. Okay, floating array, floating point values 1.1, 2.1, 3.1. This is my array with the floating point values. Okay, and then what I'm going to do is I need to create a new array and changing this floating point to integer values. Okay, so I'm using s type I, and then if I print this new array and if I print its data type, it will be something like this: 1, 2, 3, and it is integer 32. Okay, so you can change the data type, typecasting you can perform. In the next case, if I'm going to perform a change, that means I need to convert integer to boolean. Okay, so here, if you are available with any value, if you are available with which is not 0, then it will be true. It will be true always. So I am taking array 103. Okay, and I am converting it to boolean, arr dot s type bool. So my result is true, false, true. See, one is not 0, 3 is not 0, no? That's why it returned true. The value which is 0, na, it returned false. If I do consider this code again, okay, and if I would say, if you are available with -1, 0, and -3, then what will be the output? Still it will be true, false, true. So if you are having positive value, if you are having negative value, it will result you true. But if you are having 0, it will result false. That's the only case. Because if you do consider this code again and take non-zero values, okay, here if it is like 5, then it will give you true, true, true. Okay, so false is only for 0. All right, now if you want to iterate over the elements in a 1D array, I hope we have seen this stuff also. Okay, and this is one of the simple code in which you are preparing an array. Okay, 1 2 3, this is your array, and you are applying simply a for loop for x in arr print x. Okay, so it will print you 1 2 3. And in the previous class we have already used nd iter. Okay, method also to perform the iteration over the array. And apart from iteration, apart from nd iter, we have used simple iterations also for x in arr, for y in x, for z in y. Okay, it depends upon whether it is 1D array, whether it is a 2D array, whether it is a 3D array. So we have performed this task previously. Okay, so again, it's a simple example. Now, if you want to concatenate the two arrays, that means if you want to join the two arrays, the process is very much simple. Just you need to use a method np.concatenate. That's it. So arr1, okay, and 1 and arr2, you have created these two arrays, okay, and you are performing the concatenation of these two. np.concatenate. That's it. You can perform simple concatenation. All right. If you want to split the array, now again important process. If you want to split an array, that means there is a phenomena behind this. How to split? For example, if you are available with the array 1, 2, 3, 4, 5, 6, this is your array, and you want to split np dot array, there is a method called as array underscore split. np dot array underscore split arr comma 3. Okay, that means you need to split array into three parts. What it is told, arr comma 3, that means you need to split array into three parts. So you are available with the six elements. So internally, array dot split will decide what is the combination of elements I need to take to split this array into three parts. Okay, so here it is, it will take 1 2 3 4 and 5 6. That means this array is splitted into three parts. Now, if you will say, sir, there are six elements. If we need to split it into four parts, what combination my array underscore split take? Okay, so that logic will be decided by this particular method. So how it's splitted now? It took 1 2 3 4 and then array 5 and array 6. Now it converted into four splits, splitted your array. If I would say, sir, split it into two parts, okay, just split it into two parts. So, it will take 1, 2, 3, and 4, 5, 6. If you are going to say, sir, do it into one part, split it into one part. So, it took the complete array itself. Okay, if you say, sir, is there any possibility I can put 0 here? Okay, put 0. It gave me error. Nothing possible. Number of sections must be larger than 0. Point is clear. Okay, so sections should be larger than 0. So if you say, sir, six parts, I want to split it into six parts, sir. That means it is going to take each and every element now. And now if you say, sir, seven parts, now elements are six, and you are saying, sir, split it into seven part. Okay, what will happen? See, it is splitted it into six parts, and one part is taken as null. Okay, that means it doesn't give any error. Six elements are there plus one element extra, that is a null value. You can see empty array. And you say, okay, can I split it into 10 parts then? What will happen? Yes, it will. All six elements it will take. And then this is also empty. But what is the size? 32. Empty. 32. Empty. 32 integer. Again, 32 integer. That means you can't go below 0. You no consideration for 0 and below 0. But you can go beyond the number of elements which are present in the array. That means it will take the null values. Okay, it will take the null values. All right. So this is how you can split the array. And if you say, sir, what will be the shape of new ARR if I'm going to copy and print it? Sir, what is the shape? Can we check the shape also? Is it possible? Okay, now it's a list object has no attribute shape, because you know what happened? It's a list. It prepared a list of arrays. list of arrays. Okay, sir, if this is a list, so sir, we know about the list, no? We know about the list. Can we print value which is present at zeroth index position, sir? It is saying, na, list. Can we print? Okay, the value which is present at zeroth index position is 1. So, it's up to your thought process what you can do. So, the value which is present at 1th index position is 0th index position is 1. And what is the value present at, sir, 7th index position? Empty, nothing is present in the 7th index position. Okay, so whatever you got, okay, so this is a list, so I can apply list operations over it, and we have already studied about all the list operations in our previous class. Okay, so just doing some random coding and using our brain logic, okay, what we are getting. So we need to check what is the method, what it is doing, what are the possibilities, and analyze the result, what we can do with the results. Okay, next case. I guess we have already done this kind of code in which I am available with the array. Okay, okay, and I'm saying np dot where array equal to 4. That means it is going to return the my array on what index positions 4 is present. Okay, so here 4 is present here, 4 is also present, 4 is also present. So the index position is 3, index position is 5, and the index position is 6. So it's going to return you the index positions. Okay, so if I do write np dot where arr equal to 4, which is going to return you the index positions. In the last lecture, we have already seen this kind of code, and we have also prepared some other codes also related to the even number, odd number, which are returning the index position where these numbers are present in your numpy array. Okay, so it's already done. Now, there is a method sort in numpy. Okay, so we did not have to do some efforts. If you give an array which is in unsorted manner, so just use np dot sort. That's it, done, over. By using this method, you can perform the task sorting. Okay, now in the next case, because I've already told numpy supports linear algebra, numerical computation, so you can use all the stuff related to those particular concepts. So here I'm taking lcm, least common multiple. So if I'm available with the number 6, if I'm available with the number 18, if I need to calculate the lcm of 6 and 18, it will calculate. So the result is coming to be 18. Result is 18 here. Okay, and if you say, sir, is it possible for two numbers or is it possible for other number also, sir? Okay, no worries. Let us take different other numbers. Don't define it. Okay, here you can take, let me take 6, 5, 4, then 11, then 45, then 2. What is the LCM? Let me run this code. It said, what? It said error. LCM takes from 2 to 3 positional arguments, but 6 were given. Okay, so this is how you can crack. What crack? That means this is how you can crack that what my function is going to accept. That means first you need to study what function does. Okay, LCM does calculate, it calculate the sum, but how many numbers it's going to calculate the LCM? If you're okay, if you're reading, looking at the books, you're looking, okay, LCM takes two numbers. If it's not been given, generate an error and be happy. Okay, I generated an error, but this error is an information. It's not actually an error. It's an information. And information is it can take 2 to 3 arguments only, and you guys are giving 6. Okay, so 3 na, maximum 3. Okay, let us take 654, and now let me run the code. Again it gave the error. Return array must be of array type. Return array must be of array type. So what happened here? Array of array type means, that means it is troubling, still it is troubling me. np.lcm, and with 2 also it's saying type error. Return arrays must be of array type. That means whatever this is returning, it's not of array type. Okay, that means if I take only two values now, It says 30. So the point is clear. Sir, it will take only two now, sir. I can calculate the LCM of two numbers. If you think, sir, I have an LCM method in me, and you think I am a Superman, you can give 10, 20 values and ask me, sir, calculate the LCM. So it's not been happening. I do also have a life. So I can calculate the LCM of two numbers only. Okay. Now next. LCM dot reduce ARR. Now, but I we people are curious. We people are curious. Okay. We will not leave the machine so simple. And what we are going to do is, okay, we created an array 3, 6, and 9. So, we got an error above because of this only. Because of this only. It says you need to accept array. It told I can't take 6, 5, and 4. You need to give an array. Then only I can take an LCM. Okay. So, what happened? I took an array here with three elements 3, 6, and 9. And I gave array here with a reduce method. So np.lcm.reduce, this will also calculate. So this reduce, it will perform the LCM of these three. Previously, if you are using only 6, 5, and 4, three elements without reduce, it gave error. But if you are using three elements with the reduce, that means you are making this thing as an array and then giving array as an argument here to the reduce. Now it can calculate 18. Okay, it can calculate. In fact, what happened? If I do take some extra values also, if I do take some extra values, for example, if I do take 10, okay, and let me run this code. Now, sir, there is some big game happening. If I increase my array size, if I increased my array size to 4 elements, and then I am saying reduce, so still it is giving me your results are still, it is calculating my LCM. So, sir, what actually this reduce method is performing? What actually this reduce method is performing? Here we are taking the LCM and reduce method, and what's happening in this particular code? We are taking 1D array. Okay, that is 3, 6, and 9. 3, 6, 9 is an 1D array, and then we are calculating the least common multiple LCM in this array using reduce method, reducing the LCM using the reduce method from the LCM module of NumPy, and this result into your 18. So, can anyone think over it what this reduce is doing? What this reduce method is performing? What this reduce function is doing for you? Is it reducing your dimension, or is it doing something else? See, I hope that means understanding you for you is quite complex here with the reduce. So it's my turn to explain you that what actually your reduce is doing. Okay, so listen carefully. See, reduce method in NumPy is a function that applies a given binary operation to the elements in an array. Binary operation, and reduce the array into a single value. Okay. So here in this particular case, the binary operation applied by reduce is the LCM, which finds the least common multiple of the elements in the array. Okay. So what happened is now the LCM of the elements in the array is calculated successively applying the LCM operation to the pair of elements. Okay. And the LCM of the first two element is calculated, then the LCM of the result and the next element is calculated, and so on, unless and until you are going to reduce it to the single value. So no one is going to explain you and what we did here and understood what the stuff happening. Okay. So here LCM see, the logic of LCM is to consider only two element, but because of our extra curiosity, okay, we added reduce method. Okay, in that I can give multiple elements, but the logic will behave the same. That means it will first calculate the LCM of 3 6. Whatever the result will come, it will next calculate the LCM of that result with 9. Whatever result will come, it will calculate the LCM of that particular thing with 10, and then it will give you the final result as 90. So I'm reducing my array to make it in the form of pair of 2 2. That's what I'm doing. If I would say, here, sir, what happened here, sir? We are already available with the elements 1 comma 11, and if I am performing here this particular thing, that is reduce LCM dot reduce, so I am getting 2520. Is actually the LCM of 1 and 11 is 2520? LCM of 1 and 11 is not at all 2520. That means we are getting some result which is not been correct. Okay, so if you are using only two values, if you are using only two values, so I guess reduce will not give you the proper results. Okay, reduce will not give you the proper result. Its LCM is 11, because reduce works to make a combination of 2 2 in an array which is having more than two elements. But if you are available with the two elements, then its LCM can be simply calculated. Now, if you are using reduce here, so I already told you what reduce used to do. Reduce applies, this is a function that applies a given binary operation to the elements in an array. Binary operation is applied. Okay, and it iteratively reduces array to a single value. Okay, so this operation is successfully applied every time. So here some binary stuff has been done here in this particular example, if I'm going to use reduce here. Okay, and then it is calculating the LCM of those. That means it will convert this 1 into binary, then I guess 111 into binary, and then applying operation over it again and again. Okay, so it got a result as 2520, which we already seen, sir. LCM of 1 and 11 is, sir, 11 only, but if are getting the result as 2520, that means this is not correct. So if you are using only two values, don't use reduce, but if you are having more than two values, then you can use the reduce. And the working of reduce is, I'm going to take the pair of two values, and this is how we are going to find the LCM. Okay, so here your logic will not work properly. Okay, and it's not like this. You can take any other values also. If I'm saying 2 comma 11, okay, what will be the result here? It is still 2520. Okay, that means it brought curiosity in my mind. If 111 is 2520, what is 211? Okay, then what is 511? Brought me a curiosity. Again it is 2520. Again it is 2520. So what exactly this is given to me? Is it giving me false result? Because here 111 or 211 or 511 is what? Okay, one more thing you need to understand. One more thing you need to understand. We are creating an array of using a method arrange, not a simple array. No one pinged me, sir, this is arrange. Arrange means what does this arrange means? Np dot arrange means no one ping me, sir. This is not np dot array. This is np dot arranged. Arrange. And what does this arrange means? Arrange 1 to 11. What does this mean?
It means values starting from 1 up to 10.
1 up to 10 now.
An
So I
array
need
of
so I
one
need
up
to
to 10.
take the LCM of 1 to 10 values. So why you haven't told me, sir? That just I'm, the if you are listening properly, okay, if you are watching this, so you should ping me, sir. This is not you're creating an array which is using range method. That means it will take from 1 to 10, and then it will calculate the LCM from 1 to 10. Then it's give me, that is why I used 511, then I used 111, then 211. Okay, I'm trying to make you, anyone who's listening properly, at least ping me na sir. That is why I repeatedly use this code 111, 211, 511, and then it's giving me 2520, 2520. You must tell, sir, this is arrange method. Okay, so still if I take the values from 5 to 11, it's giving me 2520. Then what will happen for 6 to 11? 2520 again. If I say 10 to 11, now it is 10. That means LCM of 10 is 10 only. Okay, but if I do take 9, 11, okay, now it is 90. That is 9 and 10. LCM of 9 and 10 is 90. Okay, and then your 8, 11, 360. Okay, so understand, this is arrange method, not simple numpy array. Okay, now next, you can calculate GCD also, greatest common divisor. So 1224, the GCD is your 12. Okay, so I hope you know about the maths and you know how to calculate the greatest common divisor of the two numbers. Okay, and if I want to calculate the GCD of many numbers in an array, so obviously you know the fact. Sir, I can use reduce. And what reduce will do? Reduce, it will calculate the GCD of these two. What will be the result? Then it will calculate the result and 32. Then what is the result? With 36. Then what is the result? With 16. It will calculate the GCD by taking combination pairwise. Okay, and the result is coming to be like here 4. 4 is the greatest common divisor which can divide all these numbers. This is how we are going to calculate the GCD. Okay, what is the difference between GCD and HCF? Do you know about HCF, highest common factor? Is both are both same or different? GCD and HCF. Anyone? Greatest common divisor and highest common factor are both same or different? Tell me. This is your maths. I'm asking. Simple maths. What actually it is? Is GCD and HCF same or not? Can you hear me?
Not same.
Yeah, yeah. Yes, Ramya, say.
Both are not same, sir.
Okay, both are not same. What is the difference between HCF and the GCD? What is the difference between these
No.
two? Yes, yes. SCF and GCD. What is the difference? Tell me. Because I am available with GCD method here. LCM I am available with. But what I know is from my end, because you are in a confusion, you are right now in a dilemma. Yes, yes, say.
LCM will find the common factor,
Mm-hmm. Okay,
multiply all of it, sir.
okay, okay. So GCD, see GCD, as I told, it is the greatest common divisor, and SCF is the highest common factor, and both are mathematical terms which refer to the largest positive integer, which refers to the largest positive integer, that divides two or more numbers without having any remainder. Okay, highest common the number. Okay, um, they both are used to find the largest factor. Both are used for the same stuff, largest factor. Okay, but GCD is both are interchangeable, but the GCD in mathematics is used to describe the greatest common divisor of two or more integers, while HCF is more commonly used to describe the greatest common factor of two or more polynomial. Remember, that is the only difference. Though both the terms are interchangeable, but I am talking about the integers and I am talking about the polynomials. So GCD is used for the integers, so that's why I'm taking integer values here, and I'm trying to find the GCD between them. And HCF is used to find the GCD, the greatest common factor, only for two or more polynomials. That is HCF. Okay, so right now, however, both are we can change interchangeable. Both the terms are interchangeable. We can take the name either GCD or we can take the name either HCF. But if someone asks what is the difference, so GCD is for the integer values to calculate the factor, and HCF is used for the polynomial terms. Same thing, calculating the highest common factor only. Factor only. Okay, now next. Now, if we need to create a 2D array of all ones, then the number of rows and the number of columns as the first and the second parameters of the once method. Here is the example. There is a method called as once. I have already discussed about this particular method. Okay, so if you want to create a 2D array, okay, so with 6 rows and the 4 columns, you can create it with np.1. So then all ones will be here. And we have already seen the stuff with zeros also. Okay, then it will be having all the zeros. So here this is your 2D array, okay, with all ones. So once method is used. Okay, now with the zeros also you have seen. Okay, so np.06, that means I am going to have a 6 zeros here. This is your 1D array. Okay, and for the 2D arrays we are already again 6 4, that means here it will going to create the 2D array for the 6 rows and 4 columns with all the zeros. So just using simple methods, np.zeros, np.ones, np.zeros, just simple thing. Okay, I have already told you, that means I'm going to have an identity matrix. Okay, that means ones around the diagonals. If I'm saying I5, that means I'm going to have 5 cross 5 matrix, and all the ones will be on the diagonal. Okay, so I can prepare a matrix with all zeros also, I can prepare a matrix with all ones also, and I can prepare a matrix with the diagonal ones also. Okay, now random also I have already discussed, 4 or 5, that means 4 rows and the 5 columns with the random values. So you need to use np.random.rand. Okay, previously in case of random method you have used what? np.random.random. Okay, I let me check you this method again. Okay, so you have used, here it is, np.random.random. And apart from that, you can use also np.random.rand. That method can also be applicable instead of random.random. Okay, so here it is. This is randn is used to generate random numbers. Okay, so 4 rows and the 5 columns, and it's a normal distribution. Remember, there's again there is some thing has been included. RANDN, that means this is creating a numpy array with a normal distribution. Okay, so there are different kinds of distribution, data distribution. So this is a normal data distribution for the random values. Okay, so here is the method. Okay, if I'm going to use a method random int, that means function from the numpy module that can be used to create a numpy array with random integers with a certain range, I can do that. Okay, so here if I am saying a random randn, that means it's a normal distribution of values. If I am saying random int rand int 10 50 5, that means I need to print 5 integers 5 random integers between 10 to 50. Just print any 5 random integers. So here they are: 49, 20, 19, 35, 49. Okay, and if I do run this code again, now things will change. It's not mandatory because it's a random stuff. So with random only, you are seeing many methods which can be used. Previously, you seen random dot random. Above, you have seen random dot randin. That means for the normal distribution. And here you are seeing np dot random dot rand int. That means to print random values. Okay. So random values, and you are giving a limit here. That means I am going to print the random values between 5 to 50. That is 5 values I need to print. This is the syntax for your random int function. It specifies lower bound also, upper bound also, and the last parameter specifies the number of integers to be generated according to the definition. Now, okay, array we have already seen how to create an array. It's not a big deal. Dimensions we have already seen. Ndmin can be used to print the dimension of an array. So this thing we already know. Okay, shape we know that what is the shape means how many rows and how many columns are there. So dimension is 1D or 2D, and the shape means how many rows and how many columns are there. So this array which I have created above, this is the array which I have created above. Okay, so it's a 1D array. Okay, 1D array, here it printed, and dim will print the dimension of the array. So it's a 1D array. And if I do talk about the shape, so shape is with 6 columns. Okay, applying the loop is quite simple. You have already seen. Now, again, a bit change in the random int method. If I'm available with create an array with these values between 1 to 11, and I need to give a size 4 or 5. That means the thing is I need to create a 2D numpy array with 4 rows and the 5 columns, and the array contains integer between 1 to 10. The array is printed in this particular manner. Okay, rand int comma, here give the size 4 comma 5. So it will take random values between 1 to 11, that means excluding 11. Okay, and prepare an array with the 4 rows and the 5 columns. All these random values are there. Remember one thing, we are taking integer values only, no fractional values are available. If I do run this code again, the value will change. Every time if you do run the code again, it will pick the random values. Okay, result will be always dissimilar. Okay, so if you want to create a 2D array, so this is how you need to give the size 4 comma 5. Now the question comes, sir, can we prepare a 3D also? Is there any possibility, sir? Because we are curious people. Okay, and sir, we never settle with something available to us. So previously you gave 4 comma 5. That means, sir, 4 rows 5 columns. Now I want to give 2 comma 4 comma 5. That means, sir, I want to create a 3D array. And if I do run this code, let me check it out. Okay, so it created. So what does this 2 means? This is outer access. That means 2 rows. So here this complete is a row number 0. This complete is a row number 1. Done. What is this for? This is internal rows. Okay, row number 0, row number 1, row number 2, row number 3. What is this 5? Columns. So this is column 1, column 2, column 3, column 4, column 5. Okay, so it will prepare 3D also. You will say, sir, we are not settled yet. 3 comma 2 comma 4 comma 5. Is it possible, sir? See, everything is possible. So this is outer 3 rows. It's a 4D matrix actually. How many square brackets you are seeing? 1, 2, 3, 4. 4 square brackets you are seeing. So it's a 4D matrix. Okay, so this is how you can decide how many dimension matrix you want to create. Okay, so it will do. Give the size. Dimension, the shape you very well know. Loops you very well know. Okay, we are already applied. So to traverse all the items which are present in the 2D array, we can use to nested loop also as follows. Okay, so for example, you are available with this array 10, 12, 14, 16, 20, and 25. You applied a sample loop over it and it will be going to print you all these values because it's a 1D array. It's just a 1D array. So all the elements will be printed in the sequence. Now, now the thing is, if you want to traverse through all the items in a 2D array, we can use a nested loop, and we did that. We already did that for x in ARR and for y in x if it is a 2D array. And if it is a 3D array, then again we did that. I already told you for x in ARR, for y in x, and for z in y, which you have already done. Then it will going to print you all the elements. Here it's also printed. Okay, now next case. To add the items in a numpy array, for example, till here we created a array but we haven't added elements to it. Okay, so we can use append method. Sir, append, we remember, sir, append is something which we have used in list. Append is also applicable here in numpy module. Okay, so we need to pass the original array item and the item which we need to append it to the array using append method. So append will return the new array with the newly appended element. For example, here I am available with red, green, orange. I created an array red, green, orange. Here it is your array. And if I say np dot append, give this array also and give this color also. In case of list, it's I think it's like something list dot append, and we are going to give the value. But here method is same, name is same, but the syntax is something different. So here I'm going to take np dot append and give my array here. Okay, and then give the value here yellow. Okay, so it will append at the last. Okay, and what will happen if I am going to give the two values? You can also append an array of items to the existing array. Similar to appending a single item, we can pass existing array with a new array to the append. For example, if I'm going and it return a concatenated array. For example, I am available with red, green, and orange. This is your initial array, and I'm appending yellow and pink to it. Okay, so it will append at the last. Yellow and pink to it. It will append at the last. Now the question came, sir. Now again we have some curiosity, sir. Again, sir, this is an array. Okay, this is my array. Can we create, sir, one more array? Okay, fine, do it. Copy this thing and create one more array. This will be array 1. Array 1 will be again having the same elements. For example, red, green, and orange. Same elements will be there. And now what I'm going to do, I need to add my array with my array 1. My underscore array 1. Is it possible? Is it possible? Let me run this code. Check. You can append array by array. Okay, it's already told it will perform concatenation. It returns a concatenated array. So here, if you are available with the two arrays, so it will perform concatenation. Append will perform concatenation. And we have already seen concatenated method np.concatenate array 1 comma array 2. Same thing will be happened here in case of append. Okay, now let's proceed. Okay, zeros again, it because it's an important concept, so it's been coming again and again. Am I audible? Am I audible?
Yes, sir.
Okay. Yeah, there was just a technical issue. So, can you hear me now? Can you see the screen?
Yes, sir.
Okay.
Yes,
Okay.
sir.
Fine. So this np.0 stuff, we have seen that I need to create a matrix with three rows and the three columns, so it's quite simple. Okay, and now do some experiment with this zeros. Here in this code, if I want to add a new row to the above 3 cross 3 array, this is a 3 cross 3 array. Okay, it's a 2D array. If I need to add additional row to this 3 cross 3 array, we need to pass the original array to a new array in the form of a row vector and the access attribute to append method. Okay, to add a new array to the form in the form of a row, we need to set 0 in the access. So you know one thing, what we are going to do, access equal to 0, that means we are going to add one additional row to my existing matrix. Okay, existing. So and what elements I need to add? 1 comma 2 comma 3, because I know that there are three elements present. It's a 3 cross 3 matrix, so can accept this can accept three elements in your rows and three elements in common column. But however, I am looking forward to add three elements in the rows. Okay, so here it will add 1 2 3. Here it will add 1 2 3 at the last. Then I'm saying with x is equal to 0, I am saying go to add this elements in the row. Okay, if I do take the same code, for example, if I do take the same code, because this is very important thing to understand, else you will not be able to crack what this access means. If I run this code now, check what happened. It gave me an error. All the input array dimensions for the concatenation access must exactly match, but along with the dimension 0, the array is at index 0 has a size 3 and array at index 1 has a size 1. Okay, you can't you are trying to do access 1, then it says no sir, it's not possible. So now if I do change in this particular thing, again if I run this particular code, see, error is all same. You can't do that. Okay, so I try to manipulate the code, and initially in the concept it's been told, sir, you can add these elements in the row, x is equal to 0. That means x is equal to 0 means row. I tried to manipulate this thing and tried whether if I can add the elements in the row, can I add the elements column wise also. So if x is equal to 0 means row, then why shouldn't x is equal to 1 means column? I tried something from my side, and you know that it gave me error that there is something issue. All the input array must be the same number of dimensions. That means there is a dimension issue. You can't perform this task. Okay, so here right now we can see adding into row is possible with x is equal to 0. So I'm deleting this code again. Now, next case. If I need to append a new array as a column, now understand here. In the existing 2D array, you need to set the value of the access attribute to 1. Yeah, that's what I was doing now. But what mistake I did? See, previously my values are 1, comma 2, comma 3. Now check my values. It's 1, then 2, then 3. That means I need axis equal to 1 means column, but you need to do something with the values. Previously it was just a row values. See, this is just a row value, complete row values. Now this should be placed at row 0, this should be placed at row 1, this should be placed at row 2, and then make axis equal to 1. Now it is possible. You can see 1 2 3 are present here in at column number 4. This is your fourth column. It's been added. So just be cautious. And before seeing this code, I thought from my side, sir, I need to make x is equal to 1. Yeah, I did. But you know what happened? Giving the same set of elements in this order is actually a problematic. So the order will be like this: 1, 2, and 3. This will work. Okay. Now, delete method. So delete is something, we have seen del in our previous basics of Python. We can delete object, we can delete variable. Okay. We can delete anything. Here also we are available with the delete method. So delete method is used to pass the existing array and the index item to be deleted, okay, using this delete method. So for example, I am available with the array red, green, and orange. Okay, and I need to delete my array 1. So I'm going to pass the array also and the index also for which the element I need to delete. So at index position 1, green is present, so green will be deleted. Okay, so as the green will be deleted, I'm going to get red and orange only. All right. In the next case, if I am going to say, sir, can you delete only one element, or do you have any chances to delete multiple elements? Okay, so let's see. If I want to delete multiple items from the array, we can pass index of them in a form of a list. See, here it is: 1, 2. Okay, so it's gonna delete green also and orange also. So I'm only available with the red. Index positions 1 and 2, it's going to be deleted. Okay, fine. So if you say, sir, if I copy this code. Now, again, there is something happening in my mind. What's happening? Sir, if I'm available with orange, and if I'm available with yellow also, and if I will say delete 1 and 3, 1 comma 3. Okay, so will it delete green and yellow, or it will delete green also, orange also, yellow? What's your suggestion? Anyone? Any suggestion from your side? It will delete 1 and 3 index position values, or it will take orange also from the deletion? Any suggestion from your side before I execute this code?
I think elements from 1 and 3 index positions, sir,
Okay,
because we didn't use any colon to mention
okay,
slicing.
okay. Yes, whatever you said is, I to agree with you. That means we are not taking any colon thing. Okay, so comma is okay. Index position 1, index position 3. So 1 is green, 3 is yellow. Delete. That's it. Red and orange I'm going to get. Now, as she said, sir, sir, I am available with a comma na. If I am going to take colon, okay, she gave me one more, an idea to use an logic like 1 colon 3. Is this also possible? Let me run this code. Okay, it gave me an invalid syntax. Okay, so you can't go in a rapid pace at 1 colon 3. That means delete 1 also, 2 also, 3 also. No, no, this is, you give 1 comma 2 comma 3, but 1 colon 3 is not possible, so it's an error. Okay, let me remove this code now. If you want to delete a row or a column, okay, sir, is this any only possible to delete element? Sir, but we want something more, sir. We want to drop complete row and complete column. If you want to drop this thing in a 2D array using delete method, okay, just we did append. Previously we used an append, na? We performed append operation, okay, for adding the items. Okay, so similarly, if you want to delete a row or column using access or attribute, shall it be possible? We can use delete method to perform the deletion of a row at index 1. And here, let's see how the delete going to work upon and what access value you need to give. So for the rows, we very well know that access equal to 0. Let's first consider create an your this 2D array first. So np.random.randomInt between 1 to 11, taking the size 4 to 5, 4 rows and the 5 columns. I'm going to create an array. Okay, here array will be created. Then after deletion, I'm going to use np.delete. Okay, so previously we are using np.delete. Okay, np.delete integer random. Okay, I'm going to give this particular array, and I'm taking 1, x is equal to 0. 1, then x is equal to 0. Okay, what does this mean? This means, sir, I need to drop I need to drop which one? What row I need to drop? Row number? Row number? You can see that. Which row has been dropped? I guess this row has been dropped. Row number 1. This is your row number 0. This is row 0. This is row 1. This is row 2. And this is row 3. Okay. So if I say integer random, comma 1, x is equal to 0, it's gonna drop row 1. And this is your new array, new matrix you are getting. Okay. And if I say, sir, can you drop anything else? Can you drop 0? Take it as 0 and let me run this code. So it will drop row number 1. Okay, that means reference by 0 value. Okay, so this is your 0th row and it's drop. And this is what the result you got. You're just taking x is equal to 0. So x is equal to 0 means rows and x is equal to 1 means column. Okay, and this 0 means 0th row, here 1 means 1th row to be dropped. If I would say, sir, we are going to drop the columns. So concept is all same, no change at all. Just make x is equal to 1. That's it. Okay, you can take np.delete, np.delete, and you can take x is equal to 1 and drop whatever the column you want to drop. Okay, here I need to drop column number 1. So this is your column number 1, 7367. Okay, it will be dropped. So this is your new matrix. It's a 2D array after deletion. That's it. Okay, now sort method. So all these methods, delete, np.delete, we have seen. Okay, then we have seen your which method? Sir, zeros method, ones method, append method. Okay, and with different formulations. Okay, that means they are available with different parameters. We can give different shape also, what kind of matrix you need to create. Okay, whether you now we have seen the methods to deletion also. Okay, and deletion is quite easy. Okay, so we can delete a value, we can delete a particular value also, and we can drop the complete row and column also. Okay, so this is something quite easy. Okay, using the delete method. All right, now let's check your next np.sort. We have already seen, but let us consider some more examples over it. So for example, I am having an unsorted array. I am creating a random set of integers. Okay, 1 to 20, and I'm going to take 10 values from 1 to 20. Okay, any 10 random values between 1 to 20. This method we have already seen, np.random.randint. Okay, so I'm going to take random integers from 1 to 20, 10 different values. Okay, and then I need to sort it. So using np.sort I can. Okay, so these are the values unsorted. Okay, and these are the sorted values for it using np.sort. Okay, now in the next case, if you are available, sir, is it only with the work with only numerics? No, it doesn't mean that it works only with the numerics. It works with your text data also, text arrays, and it is sorted into alphabetical order. And you have already seen this kind of sorting in case of list. Okay, if I'm available with red, green, blue, yellow, and if I will say np.sort my array, so it will do it. Here also the same thing was happening. Just we created our numbers using random int. Here we have created a sample array. Okay, and it will sort it. Blue, green, red, and yellow. Okay, now let us bring some twist. What will happen to the lowercase and uppercase? If I'm having red, green, blue, yellow, and if I say in quotation orange, okay, what will happen? And if I say black, what will be the value it will going to tell you? Same thing which you have seen in case of list. In case of list also, na preference was given to the uppercase characters and then lowercase. So this is sorted separately and this is sorted separately, but it will come after your uppercase characters as same as that of the list. Okay, now next case, if I need to sort the boolean values also, whether it is possible or not. Boolean values, okay, so here boolean arrays are also sorted in the way all the false value appear first and the true value will appear last. Okay, for example, you are having a boolean false true true false false true false true. You can sort it, and false will come first and true will come at the last. So if I would say, here I am not writing them into quotation, in quote false. Okay, that means f is having priority over t because f is coming prior to t. No, it's not like that. This is actually a boolean value only. These are boolean values only. So I'm going to sort the boolean values. Okay, so false will come first and true will come after to it. Okay, now, sir, how to sort elements which are present in a 2D array? Sorting elements. See, 1D sorting is, sir, understood, sir. But what will happen for the elements which are present in a two-dimensional array? Okay, for example, I'm going to create a 2D array with 1 comma 20. That means take the range of values between 1 comma 20 and prepare a 2D array with 4 rows and the 6 columns. 4 rows and 6 columns. And perform sorting over it. Sort. Okay, so here it is. Okay. And how it's sorting? Sir, the sort function sorts an item in each individual array in a two-dimensional. Okay, and here you can see that are we considering row for the sorting? Because let us check this particular row. The minimum value is 9, then 9, then 12. So 9 9 12 17 19 19, and then 2 4 10. Here it is. So if we are available with the 2D array, then it is going to sort the values according to the row. Okay, not according to the column. Okay, and we are just using again a sort np dot sort and giving the array. No hard and fast thing we need to do, whether it's a 1D array, whether it is a 2D array. We do not have to think over much. Okay, just give it. So here I have prepared a 2D array. And if it would be like 3D also, if I do consider this code and prepare a 3D, and then I am looking forward to perform a sorting. For example, if I would say, sir, make a size 2 comma 4 comma 6 and then perform sorting over it. Let me run this code. Okay, it will do it. There is no thinking or big thought process to perform this. It's a 3D array, and here it's a sorting of a 3D array. Okay, row wise only it will sort. Now we can also sort an array in descending order. Sir, previously we are just going only sort method and giving the array into it. Okay, is there any method, anything, any technique so I can sort it into descending order also? Previously it's all everything like in ascending order only. For descending, is there any way? So you can pass the sorted array to the flip flip ud flipped method that will reverse the sorted array and returns the array into sorted manner, into descending order. How? This is your initial array, 1D array. Between 1 to 20, you are going to take 10 values. Okay, so it's an initial array, and then you are performing sorting over it. np.sort, you did sort it in an ascending order, and then whatever be the sorted arrays, give it to flip ud. Give it to flip ud, and it will sort it into descending order. So here there is no technique like we are saying right now. What we know previously is np dot sort. Np dot what I learned is there is one more thing, that is np dot sort. And if you give this particular array, and you need to make see, I can write this thing. Okay, there is what I learned about one more stuff, that is sending equal to false. Okay, then it will convert into descending. What I know something about sort thing also. For example, if I don't want to use this particular flip UD method, for example, let us consider this code again and check whether this particular instance is correct or not. Okay, so let's have a check. I am copying this code again, okay, and putting it here. Okay, and just trying to experiment that make ascending equal to false. Copy, and instead of using this particular thing, reverse sorted, make this stuff ascending equal to false. Okay, and I'm going to delete it. Whether this will work or not, it gave an error. Sort dispatcher got an unexpected keyword argument ascending. So you can't give an argument here that is ascending equal to false. That will convert this into descending. Okay, so we need to use that method flip UD to perform the sorting in descending order. Okay, now next reshape. I guess we have done some stuff related to the reshape also. And for example, here is you are available with 1 to 20 random values. I require 10 out of it. Okay, and if I need to perform a reshape 2 5, that means remember I've already told you previously 1 to 20, and you are saying, sir, I require 10 elements. So reshape should be done in such a manner that the multiplication of these two will be equal to the number of elements. So 2 5s are 10. Okay, so the reshape should also be done in this manner only. 2 5s are 10 elements. Then it should be like 2 rows and the 5 columns. Okay, if you give reshape 3 comma 5, it will give you error. 3 comma 5 is not possible. 5 comma 2 is possible. Here, instead of 2 5, you can give 5 2. It will give you result because the number of elements are 10 here. So reshape of elements number should be compatible match with your this thing reshaping. So how to get 10? Either 2 into 5 or either 5 into 2. You will say, sir, can we reshape it with one more because this is a 2D thing now. Let me first run this code. Okay, I got this result. Now I want to do something more stuff. That means I need to reshape it in a form of a 3D. I want to make it as a 3D thing, not 2 3. Is it possible? Is it possible to make it as a 3D? I'm going to take one also, 1 comma 2 comma 5. Okay, and let me print it 3. Okay, because 1 into 2 into 5 is 10 only, no? Whether this is possible or not, let me print it. And I got it. Yes, it is possible, sir. Okay, that means you can add one more excess, but the multiplication should have to be 10. Okay, sir, if can I use 0, sir? Can I use 0? Again, do some experiment. Make it as 0. Okay, will it be possible? Cannot reshape array of size 10 into shape 0 to 5. No. Your multiplication 0 into 2 into 5 is 0. Not possible. 1 is possible. Not this thing. Okay, so it will give you error. Done. Fine. So here you can perform the reshape. And now what's the method how we are performing the reshape? You are saying, sir, this 1D dot reshape, this is what we are taking. So what is the another way to perform the reshape? For example, it is important to mention the product of the rows and the columns of the original array that must match the product of the rows and the columns of the reshape array. Okay, number of elements should be, you should be knowing about this thing. 2 5s are 10. That's what we have seen. For instance, the shape of the original array is 10. No, we are available with the 10 elements in the 1D array. Okay, then we have seen, sir, it should be 2 cross 5. Now you can also call the reshape function directly from the numpy module and pass it the array to be reshaped as a first argument also. For example, this is my array. Okay, this is the array which I have created, and I'm giving this 1D array here as an argument. Okay, previously what I was doing, I am using this array, 1D array, and then dot I am performing reshape. Now I can give np dot array, np dot reshape, and inside that only I can give this array and perform the reshape also directly in reshape method. Okay, so the task will be all same. 2 rows and the 5 columns. It will convert into 2 rows and the 5 columns to 2D matrix. This 1D stuff. Now we can save and load numpy array to our system also. This is something new which you haven't seen, learned, or whatever. Okay, I know that you are also not aware of this much kind of different codes and these methods which can be applied over numpy, though you have learned some basics of numpy but not that much. Okay, now there is something extra. I am saying you can save and load a numpy array to and from your local drive. To save a numpy array, you need to use a save method. So there is a save method present. Okay, so I am using import numpy as np, and this is my numpy array, and I am saving this array in my system with a name. See, there is a folder in D drive. For example, here is a path I need to give. In my system, there is a folder available in D drive. Name is Python. So I'm saving this particular array 1 in my Python folder. Okay, and if I need to check that how it looks like, okay, so I need to go for in that particular drive, and then I need to look out at how this array 1 is going to look like. Okay, and the next thing is I need to upload this array also. Okay, for example, let us first okay, let me run this code. This is how you can save your array. Okay, with save a method np.save. Okay, and then the save method saves array in npy file format. Okay, this is the file format. This is the file format by which your array will be saved. .npy. Npy means numpy array. npy means numpy array. This is the file format with the help of which you can save an array. Okay, now we can also save this array in a format of a text file. In text file format also we can save it. Okay, so how we are going to write the code in my D drive, in my Python folder. I need to save it like this: my underscore array dot txt file. Just name in a text format, no? So you need to give a file name, my underscore array dot txt. So this will be the file name. Okay, by which you are going to save your this file. And if I do run this code, my underscore array txt. Okay, and I need to check in my D drive. Okay, let me share you that particular thing, that how it's look to you. Okay, let me share the entire screen. Okay, and here it is. Okay, you can see my array. This is present in my D drive in Python folder, and I have saved the array. And if I do click it, here is my array. This is my file, text file, where array has been stored. So you can save your array, okay, in npy format. Okay, the format will be, previously I told that your format will be like this thing. What? .npy format. If you just simply save it, so its format will be npy. That means numpy array. Okay, and if you want to make it some simple format which is easier for you to understand. Okay, so text is something which is easier for you to understand. So that's why I saved it in txt format. Okay, and I have already shown you in my folder where it is present. So you can give the path. Path is important here. Give the path and save it. Okay, now to load a numpy array in a numpy format, you can use load method. See, if I have already saved, but now if I need to load it, I need to load it back. Okay, so I need to use a method that is called as load method. So for example, let us create an array. For import numpy as np, a equal to np dot array I plus j for I in range of 5, for j in range of 5. That means I'm using this nested loop, and I'm saving and I'm creating an array with this particular nested loop. Okay, and I that means what? I'm taking I plus j for I in range of 5 and for j in range of 5. That means from 0 to 4 and again from 0 to 4. For I and j both the values, and I'm taking the addition of it. So an array will be created here. And I'm going to print this array, print this particular array. So this is the array which has been present. This is an array, and I need to save this array. Np dot save file dot a. So this is your array name. Save it file dot a, file dot a. So it will be saved in your drive from which you are currently working on Jupyter Notebook. So currently I am working from my C drive. Previously I gave a path that save this thing into Python folder of D drive. Currently I am working from my C drive, and there is a Python folder from which I'm running my Jupyter Notebook. So now this file will be saved to there. I haven't given the path to save in D Python. If you're not giving path, then it will be saved at that particular location from which this particular stuff is working on. Okay, and then if I need to load this particular file, which is in npy format, numpy format, so I need to write np.load file.npy. It will load your numpy file. Okay, and the array which has been loaded, okay, that is print b, whatever be the loaded now. I can print it. I say b equal to np dot load. That means assign the contents to b and print b. Oh, and then say b is printed from the file. So here it is. See, and the contents will not change. Contents is all same. So this is your numpy array. It has been saved in your hard disk. Okay, in .npy format, and you have again loaded this particular file, and you are printing this particular file. Okay, and if you have saved in text format, so you can use load txt. If it is not numpy, then use load txt. Previously you used load only. Now you can use load txt to open text file. Okay, to see the contents of numpy array which has been stored in a text format. So you can use this thing, load txt. Now you can calculate various other statistical operations also on the numpy. That means you can find the mean, median, standard deviation of the numpy array. You can perform this task. Okay, to find the mean average, what is the mean? Mean is the average of all the items which are present in the numpy array. So just use mean method. That's it. This is your numpy array, and use mean. Np dot mean. Np dot mean. That's it. It will calculate the mean of the array. And if you want to calculate median, so let us check for the median also. Copy and paste it here. Okay, use a median. Is there any method directly median? Okay, let me run this code. It gave the result as to you as the median. Now the question is, what is mean? You know, sir, it's an average of all the values. Can anyone tell me what is median? What is this median? What is median? What do you mean by median? Rishmita, what do you mean by median? Can you please tell me, Rashmita, what is median? Anyone can tell me what is median? See,
Yes.
yes, yes, say, yes, say, what is median?
Sir,
Yes,
hello.
yeah, yeah, say.
Sir, this is Rishmita. Most of us have are having problems with our Wi-Fi connections.
Okay, okay,
That's why we keep logging in and logging out.
yeah, yeah, it's
So I'm
looking.
now using someone
Yeah,
else's.
yeah, yeah. I can understand. There is some issue. Okay, so yeah, median value. Can anyone tell me? See, median is see median value. That means yeah, 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 yeah. What value it is? It's a center value.
Uh, the center
Center
value,
value
yes,
of your
sir.
data sets. Okay, so this is your data set 2, 4, 8, 10, 12. So the center value will be 8. Okay, so that's why I told you that the median here, I calculated the median that is given to be 12, 8. Okay, now if I would say what is mode, if I, is there any availability of mode value also? What is mode?
The number of times an element is
Okay,
repeated.
number of times an element is repeated. So can I take np dot mode? Will it give me some result or not? Give error. Numpy doesn't have any mode stuff. Okay, numpy cannot have any mode stuff because the definition of mode itself says na number of times then element is going to repeat itself. So mode is not been going to give you directly what actually it is. Okay, now next. This thing we very well know, but the point is if we need to calculate the mean about the axis, okay, about the axis of the elements. For example, if I do create 2 comma 3 a 2D matrix with 2 rows and the 3 columns, a random integers 120 with the 2 rows and the 3 columns, and if I would say that calculate np dot mean x is equal to 1 and np dot mean x is equal to 0. So this is your 2 cross 3 matrix. Mean about what? X is equal to 1. X is equal to 1, that means column wise. That is a column. Okay, so the mean of column is your how much? Is 16. So mean about columns, and what result you are getting here? 16 and 12. And mean about x is equal to 0, you are getting a result of 16.5, 16 and 10.5. Okay, so if you want to find the mean in the two dimensional for array rows and columns, to find the mean across the columns you need to pass one as the value of the axis parameter for parameter of the mean method. Similarly we can pass 0 for your rows. Okay, so here it is, and we have already seen x is equal to 1 means columns, so you need to find the mean about columns. So here the mean is coming as 16 and 12.667 about the columns. Okay, let me print it one by one. If I do run this code, okay, now here is the mean for the columns, because we are available with how many columns? How many columns are there? We are available with 2 rows and 3 columns we are available with. 2 rows and 3 columns we are available with. Now the question is, I got two mean values. Now this is a big question, sir. If you are getting two values, we are having 3 columns, you are using x is equal to 1, sir, how can you say, sir, this has been possible? What could be the idea? So if I say 12 plus 27 is how much? 12 plus 15, 27. 27 plus 8, that is 35. If I divide 35, how many elements are there? 3. How many elements are there? 3. So 35 divided by 3, how much it is? 3 ones are 3, then again 3 ones are 3, then 11.666. Okay, I got it. Sir, if you say I need to calculate mean about x is equal to 1, it means that I need to operate over rows. Understand, that is complete logic is ulta pulta. Logic is all changed. Focus on the value. It means x is equal to 1 for the column, but you know what happened here? The mean of rows has been calculated, and if I say x is equal to 0, that means column, but the mean of what? X is equal to 0, that means rows. Okay, but the columns mean has been calculated, that means all reverse process. So when I am having x is equal to 1, that means columns, but mean of rows is calculated. And if I'm having x is equal to 0, that means columns, but mean of that means rows, that means mean, but mean of columns is calculated. Okay, here is the case. If I do run this code again, this is the result which you got: 7, 9.5 and 15.5. Okay, so this is the mean. Median, I've already told you, median is already we worked. Okay, we can calculate the median also, about x is equal to 1 and x is equal to 0, same thing. Okay, if I'm going to take x is equal to 1, that means it's going to work upon your rows, and if I'm going to say x is equal to 0, then it is going to work upon the columns and calculating the median. Very simple methods again. Minimum value and the maximum value, very simple methods. Max function will return the maximum value from the array, min function will going to print the minimum value from the array. Okay, so here if I use min, this is my array, and if I'm going to use np dot a min, so it is going to print you minimum value 2. In this particular array I am having a minimum value 2. For example, let's copy this code, and it's told that you need to use min method, not a min. If I going to use min method, let me run this code. Here also it's same. So min or a min, it doesn't make any sense. Okay, so min method can be used to print the minimum value out of array, and max value is going to print you the maximum value out of the array. So if I do copy this code, okay, and use max, so it will print you the max value. Max value is 12. Okay, so min and the max. And also you can apply this stuff on axis also. For example, if I would say what is the minimum value in x is equal to 1, that means your what? X is equal to 1, that means columns. I'm talking about the columns. Okay, so if I do talk about the columns, what it's going to tell me? It's going to tell me I am having the minimum value about, I'm talking about, if I say minimum value about the columns, it will say row, it will talk about the rows. Okay, so here I am taking x is equal to 1, but it will find what is the minimum value in rows. So in row, in this particular row, minimum value is 8. In this particular row, minimum value is 2. In this particular row, minimum value is 2. So 8, 2, 2. And if I say x is equal to 0, which actually means rows, but it will work upon columns. So the minimum values in columns are, in this particular column 8, in this particular column 2, in this particular column 2, in this particular column 7. These are the minimum values. Okay, so all this thing are changing. With x is equal to 1, it's looking forward for the rows. With x is equal to 0, it's looking forward for the columns. Okay, and this is simple. Using max method, I can print the maximum value. I've already told you. Okay, and max also was the same as we did above. Minimum values about your rows and about the columns. Previously, we did use a min method. Here I'm using a max method. It will print you the maximum method, maximum value present in rows, and the maximum value present in the columns. That's it. If I need to calculate the standard deviation, that means the distribution of the data. STD means Data distribution, standard deviation means this is your how your data is distributed in a plane. Okay, so if I'm going to use that particular stuff, std np.std, standard deviation, this is your standard deviation 3.7. That means this is your array. Simple, you need to take your array and use np.std. That's it. It will calculate your standard deviation. So we have used np.mean, max, std, mean, median, except mode. Mode is something else. Okay, so we can use directly out of array and we can print them. Direct methods. Okay, you can calculate the standard deviation about rows and columns also. Same stuff as we did with the max and as we did with the mean. If I do talk about x is equal to 1, that means it stands for the columns. However, it will calculate the standard deviation for the rows. That means whatever the process which was happening previously, now it is happening here also in the same way. Okay. Now the next thing is correlation. Correlation. We can find correlation also between the two arrays. Okay, so there is a method called as correlation. This method, we need to pass it on the two numpy arrays between which you can find the correlation. Okay, so here it is. I'm available with the array. This is your array 1, this is your array 2, and I'm np dot correlate a1 comma a2. So I'm finding the correlation between them. Okay, so finding correlation between your two arrays, what does this actually means? Finding correlation between two array. Correlation. It calculates. See, I hope you don't know. So the point is the correlation np dot correlate function calculates the correlation of the two arrays. Okay, that means how these two values are going to behave with each other, whether they are directly proportional, whether they are inversely proportional. Okay, so you need to take care of the relationship between the values which are present in the two arrays. Okay, that means the correlation is the similarity between the two arrays, and highly correlated indicates that two of them are having good correlation with each other, and least value of the correlation means they are least correlated with each other. Okay, so here I can check that these values are 1, 3, 0, 0.9, 1.2. These values, this is minus 1, 0.5, 0.2, 0.6. That means how these values are correlated with each other. In our data science also, we create a correlation matrix. So it let us know that how these features are behaving. That means if increasing in one, how it has been reflected to another one, whether another one also increases or whether another one also decreases. So how these two values are correlated with each other in form of increasing, decreasing, okay, change in the value, does it reflects back to the change. So this is how correlation has been going to take. Here the correlation is 7.04. That means they are highly correlated. More than 5 score is coming. So these two array values are correlated to each other. Okay, now if I need to find how many unique values are present in the array, for example, I am having repeated numbers 5, 8, 7, 5, 9, 3, 7, 7, 1, 1, 8, 4, repeated values. And now if the question is being asked to you, what is the unique values present in the array? What are the unique values? So just use direct method, unique, np dot unique method. Okay, so it will give you the unique elements present in your array. And if you say, sir, count also, count how many unique elements are there, so it will return you the count also. So for that reason, you need to do one thing. This is your array. You take two variables, unique items and the counts, and put it here in the same method, np dot unique, as we have used previously, np dot unique. Okay, and just use here return counts equal to true. So it will let you know that how, okay, 1 is present 2 times, 3 is present 2 times, 4 is present 1 time, 5 is present 2 times, and so on. It will return how many times they are present. So it will return the counts also. So you, with unique method, you use return underscore count equal to true. Okay, so here it's all same. All right, fine. Calculation. We have already used this to reverse an array. Okay, descending order. Okay. So working with the CSV file that we'll see in the pandas. Okay, so that we'll see the next. So here I finished your Numpy stuff. Okay, your Numpy library is over. Okay, let me stop the recording.